So, Lucas Dillingham from Brighton Science. One of the new things that we've developed this year is a connected platform for manufacturers doing surface critical processes. So think molding, cleaning, bonding, sealing, precision cleaning, surface treatment. Our company for many years has developed and sold instrumentation to put data to surfaces that are critical for manufacturers to be right, to be successful. And so one of the things that we've done this year to kind of enhance that and make that better is we've come out with our BConnect platform. And that's a combination of a connected piece of hardware and a software platform that allows people to build a materials database, a library if you will, create experiments, publish them anywhere in the world, and get that data back in real time. So like as an example, if I'm sitting in Seattle, Washington, but I'm collaborating with a team in Japan on a component, I can actually work with them in real time to understand, hey, am I cleaning that part well today? Or do I have contamination? Or is there a difference from one corner of the part to the other? And people are doing this all in service to solve problems faster, build their own internal knowledge, and at the end of the day, build a smarter, better, faster, cheaper component. What we've got here is a new connected surface analyst. All right, this is measuring water contact angle. It does so in about a second and a half. And what we do here is we actually create experiments in a web platform that show up right here on the instrument. So I could be located anywhere in the world. I can select the instrument that's been assigned to me, and I can begin an experiment, right? And the way this thing works is much like a small printer. So what I do is I take my measurement head, I put it in contact with a surface, I hit the trigger, it deposits a small water droplet and returns what's called a water contact angle. So this is the angle that the perimeter of the droplet makes with the surface. The lower the number is, the more reactive the surface is, the cleaner it is, you can think of. The higher the number is, the more hydrophobic or less clean it is, or non-stick if I'm doing any kind of molding. Thinking about composite applications. The nice thing about this is that it's really quite flexible, right? So like I can take this device and I can measure any orientation. So if I want to measure upside down, I can measure just upside down. So if you can imagine, if I'm making a composite part, right, I can actually get all around a tool surface, and I can even 3D print different attachments to make it really easy for the operator to do this sort of thing. In terms of composites, it's going to be folks that are doing, I'll say, molding, painting or bonding, and then repair of composite structure. So think about like repairing a wind turbine, or repairing a part of the aircraft, or making a golf club, making sure that that face stays bonded onto the frame of the golf club. Specifically from a marketing standpoint, our go-to-market strategy is to deal with anybody who's building composite materials or working with composite materials. So this can be used and is used on any solid surface where it's critical to have the right surface energy for that thing to work right. So it could be surface treatment of metals, it could be cleaning glass, it could be coating glass, it could be applying sealants to battery packs and e-mobility applications. We kind of boil it down to if you paint, bond, coat, seal, or clean, then you have the opportunity to take advantage of something like this.